Have you ever wondered if we're truly alone in the universe? That question has driven us to send probes like Voyager 2 into the vast unknown. But in 2024, Voyager 2 sent back a signal so strange it sparked confusion and excitement at NASA. The data stream flickered, the signal wavered, and suddenly, a mysterious transmission appeared. Was it a technical glitch or something more? The incident forced scientists to confront the immense challenges of deep space communication. Before we unravel the mystery, let's look at the incredible journey that brought Voyager 2 to this point. To truly grasp the significance of any message carried by the Voyager probes, we have to step back and appreciate the sheer scale and vision behind their creation. These spacecraft were not just machines, they were ambassadors, built by human hands with the hope of reaching the unknown. The mission itself was a bold leap into the cosmos, a testament to human curiosity and ingenuity. In the 1970s, as the world watched, NASA scientists and engineers dared to dream bigger than ever before, planning a journey that would stretch the limits of technology and imagination. A rare planetary alignment, occurring only once every 176 years, presented a unique opportunity. NASA seized the moment, launching Voyager 1 and Voyager 2 on what they called the Grand Tour, a mission to visit the 4 giant outer planets in a single sweep, using gravity assist to slingshot from one world to the next. In 1977, both probes thundered into space, each packed with a suite of scientific instruments designed to unlock the mysteries of Jupiter, Saturn, Uranus, and Neptune. For the first time, humanity would see these distant worlds up close, revealing details that had only been imagined. But the Voyagers carried more than just cameras and sensors. Each was equipped with the Golden Record, a gold-plated phonograph containing sounds and images from Earth, greetings in 55 languages, and music from across cultures. It was a message in a bottle, cast into the cosmic ocean for any intelligent life that might one day find it. As Voyager 2 journeyed past the gas giants, it sent back breathtaking images and data: the swirling storms of Jupiter, the intricate beauty of Saturn's rings, the mysterious tilt of Uranus, and the discovery of Neptune's dark spot. Each encounter rewrote our understanding of the solar system, filling textbooks with new knowledge and wonder. After Voyager 2's historic flyby of Neptune, its planetary mission was complete. But the story didn't end there. Both probes continued their journey, venturing into the vast, uncharted territory beyond the planets, into interstellar space, where no spacecraft had gone before. Out there, far beyond the warmth of the sun, the Voyagers became humanity's distant eyes and ears, sending back faint signals across billions of miles. They continue to teach us about the edge of our solar system and the space beyond, carrying our hopes and questions into the unknown. The story of the Voyager probes is one of ambition, discovery, and hope, a reminder that, even from our small world, we can reach out and touch the stars. After their planetary flybys, the Voyagers set out for interstellar space, uncharted territory beyond the sun's influence. For decades, they sent back data from the edge of the solar system, operating on 1970s technology with less power than a car key fob. Their power's fading, and NASA has had to shut down instruments to keep them alive. Today, both probes are over 15 billion miles away. Every command takes nearly 2 days for a round trip. Voyager 1 crossed into interstellar space in 2012, Voyager 2 in 2018. They are the first human-made objects to experience this environment, carrying our golden records into the galaxy. This epic context made the recent signal anomaly so compelling. The real mystery began with Voyager 1 in October 2024, when a routine command sent from Earth set off a chain of unexpected events. This was no ordinary day for the team at NASA. For decades, Voyager 1 had been faithfully sending back data from the farthest reaches of our solar system, a silent ambassador drifting through the cosmic void. But on this day, something went wrong, something no one had anticipated. The command, meant to check the spacecraft's health, instead triggered its fall protection system, a kind of automated safety net designed to keep Voyager safe if it ever sensed trouble. Suddenly, the probe's behavior changed, and the mission team was left scrambling for answers. Without warning, Voyager 1 switched from its main X-band transmitter, which had been its primary link to Earth for over 40 years, to a much weaker S-band backup. This backup system hadn't been used since 1981, and its capabilities were limited compared to the main transmitter. The S-band system was a relic from the early days of the mission, a backup that most engineers had only read about in old manuals. Its sudden activation was both a surprise and a concern. In an instant, NASA lost the powerful, data-rich signal they relied on. Instead, all they could pick up was a faint, barely there whisper on a different frequency. The information coming through was minimal, just enough to confirm the spacecraft was still out there. For nearly a day, mission controllers were left in the dark, anxiously monitoring their screens and running through possible scenarios. Was it a hardware failure, a software glitch, or something even stranger? When the S-band signal was finally detected, it brought a wave of relief. Voyager 1 was alive, still communicating, but only able to send the most basic status updates. No science data, no detailed telemetry, just a heartbeat in the void. The team could see that the spacecraft was still functioning, but its ability to tell its story was severely limited. It was as if Voyager was whispering from across the cosmos, unable to share the wonders it was witnessing. News of the anomaly quickly spread, and confusion in public reports led to wild speculation. Some wondered if Voyager had intercepted a mysterious signal, or if it was sending secret messages. Others even speculated about the possibility of alien contact. In reality, the explanation was far more down to earth. Voyager 1 is an aging robot, a marvel of 1970s engineering, now billions of miles from home. Its systems are old, its parts worn, and it's constantly battling the harsh environment of deep space. Alone in the darkness, Voyager was simply trying to protect itself the only way it knew how, by switching to backup systems and waiting for help from Earth. The incident became a perfect storm for rumors and internet theories, fueling debates and discussions among space enthusiasts and the general public alike. But behind the scenes, the real story was unfolding. A fascinating engineering challenge for NASA's best minds. They pored over blueprints, analyzed decades-old code, and brainstormed solutions late into the night. The real question now loomed large. Could NASA bring Voyager 1? On down. Restore its voice and continue its journey of discovery across the stars. The world waited, holding its breath, as the mystery deepened. NASA's engineers faced a daunting task: diagnose and fix a spacecraft 15 billion miles away, with each message taking 2 days round trip. They analyzed the limited S-band data, ran ground simulations, and pieced together the chain of events. The culprit? A software misunderstanding triggered by the heater command, causing the probe to enter safe mode. Fortunately, this meant the problem was likely fixable with a software patch, not a fatal hardware failure. The next step: carefully command Voyager 1 to switch back to its primary transmitter. A risky maneuver. Every command had to be precise. A mistake could silence the probe forever. The episode showcased the ingenuity and patience of the team keeping these ancient explorers alive. It was a triumph of human problem-solving across the void. Communicating with Voyager is nothing like a phone call. It's a feat of engineering that pushes the limits of what's possible. Imagine trying to whisper to someone on the other side of the world through a hurricane, with only the faintest hope they'll hear you. That's the challenge NASA faces every day. The signals Voyager sends are unimaginably weak, billions of times fainter than a watch battery. By the time they reach Earth, they're so faint that even the most sensitive receivers struggle to pick them out from the background noise of the universe. It's like trying to spot a single firefly from across a continent. To catch these whispers, NASA's deep space network relies on enormous antennas, some as wide as a football field. These dishes scan the sky, searching for Voyager's signal among countless other sources of radio waves, both natural and man-made. But space is a noisy place. Solar flares erupt from the sun, sending waves of charged particles racing through the solar system. Cosmic rays zip past at nearly the speed of light, sometimes disrupting signals. Even back on Earth, our own electronics, cell towers, radio stations, and city lights can create interference, making every signal a puzzle to decode. Engineers must filter out this static, searching for Voyager's faint voice amid the chaos. When Voyager switched to its S-band, it was like changing both the language and the volume of the conversation. Suddenly, the familiar patterns of communication shifted, and NASA had to adapt quickly, recalibrating their equipment to understand the new signal. NASA could tell the probe was alive, but not what it was saying. Misunderstandings are easy. A shift in frequency or a burst of static can seem mysterious, even alarming, when you're listening across billions of miles. Sometimes a sudden burst of static or a garbled message can spark speculation. Are we hearing something new, or just another technical hiccup? But for the engineers and scientists, these mysteries are usually just technical issues. Problems to be solved with patience, expertise, and a bit of detective work. They analyze every blip and anomaly, determined to keep the conversation going. The real marvel isn't just that we can talk to Voyager, it's that despite all the obstacles, we can diagnose and fix problems across billions of miles, keeping humanity's farthest explorer connected to home. So, what was behind the hidden Voyager transmission? No aliens, no cosmic phenomena, just a predictable engineering issue. The switch to the S-band was unexpected, but not mysterious. The probe was simply following its programming to protect itself. The real mystery was why it happened, not what the signal said. NASA's investigation revealed a software hiccup in a 1970s computer. This incident highlights both the fragility and resilience of our deep space explorers. Every glitch is a lesson in operating spacecraft over vast distances and timescales. The Voyager mission is now as much about engineering endurance as scientific discovery. The story is one of triumph human ingenuity keeping a lonely robot talking to Earth. The Voyager anomaly reminds us of our deepest impulse, to explore. These probes are our eyes and ears in the cosmos, pushing the boundaries of what's possible. Every bit of data, even a simple status report, expands our knowledge and inspires us. Voyager's journey is a monument to human curiosity and collaboration across generations. Even after they fall silent, the probes will wander the galaxy for millions of years, carrying our message of hope. These missions challenge us to think bigger, to reach farther, and to keep listening. The quest for knowledge is a journey without end. As long as there are mysteries in the universe, humanity will be there, listening for the next whisper from the void.